In this slide, you can see JWST.
Europa is a big target for NASA exploration because we have very high evidence that there is some subsurface, maybe water reservoirs on Europa. We took the data from Europa a few weeks ago. Maybe I think Europa was like 10 days ago. So the data just came back from the telescope raw, and it actually became public immediately the moment we saw it. And we got these email alerts and say, oh, the data's there, the data's there. And then you go to the data and it looks like, very tricky because it's raw data, pixels to pixels. So you spend nights and working on the data, everybody's working, oh, what is there, what is there? And now today, we didn't know what to do about the meeting. Should we wait for the paper or should we make it public? And we say, look, the data is public, let's tease people also because they see this cool data, maybe astrobiologically relevant or habitable or maybe potential for life.
Jupiter is the largest planet in the solar system, and if people have a mental picture of Jupiter, they might think of it with its great red spot. And the planet Earth could easily fit inside that great red spot. In fact, you could fit 2 Earths inside the great red spot. So it's a much, much larger planet than the Earth. And it's a fundamentally different kind of planet. We call it a gas giant because when you look at Jupiter, all you see is swirling gases. And if you could strip away that outer layer of gases, like by magic, underneath it you would see more gases. And if you took away those gases, even more, it's gases all the way down. It doesn't have a solid surface with an atmosphere. It's all atmosphere until you get like deep, deep, deep into the core of that giant world. Galileo actually looked at Jupiter with his small telescope and made an astonishing discovery that there were tiny dots that seemed to be orbiting Jupiter. And this was the discovery of the 4 largest moons, which today we call the Galilean moons. And that was really crucial at that time because it was the first time we had evidence that our Earth was like not the center of things. Here was a system where other things were the center. Jupiter was the center of that system.
So when Galileo first discovered there were some moons around Jupiter, we didn't know anything about them. We just saw they were small, pretty bright, nearby, going around pretty fast around Jupiter. But then we were lucky to have a few missions to go through the systems. One first was Voyager.
Scientists at Cape Canaveral, Florida sent another unmanned Voyager spacecraft on its way to Jupiter and Saturn today. It lifted off flawlessly at 8:56 a.m. This Voyager presumably will get to Jupiter in March of 1979.
Dr. Smith, can you offer yet any kind of a historical scenario for the cracks on Europa? Why they're there?
No, Rick, I cannot. I'm sorry. No, I think we really, we've had these pictures in hand for something like 24 hours or so, and I think we really don't begin to understand these features that we're seeing on Europa. It was no surprise that we should be surprised. Europa looks very different from the other satellites.
And they had remarkable surprises all throughout the Jupiter system.
And we got some very nice pictures in late yesterday afternoon and last night of the inner 2 satellites, Io and Europa. which I'd like to share with you. And it looks very unlike any of the other satellites in the style of the contrast we're seeing, and also quite unlike any other planet we've seen. For instance, you don't see lots of dots or large, irregular, circular-shaped regions of darker material. What you see is more or less fuzzy boundaries, and then these rather sharp, semi-linear features that sort of reminiscent of fracture patterns or something of that sort. And these are big features. They may be between 50 and 150 kilometers across. They're several thousand kilometers long.
It was a spacecraft named after Galileo himself that was put into orbit around Jupiter.
The spacecraft is stable. Galileo is on its way to another world. It's in the hands of the best flight controllers in this world. Flight safe.
And this was a challenge spacecraft because its main antenna didn't open.
Galileo certainly was the most problem-plagued interplanetary project ever.
We had this spacecraft that we couldn't touch. It was so far away, and it had such a huge hardware problem.
We had this Highgate antenna failure, we had the tape recorder. All throughout, we had one adversity after another.
And so they had to use one of the small antennas on the spacecraft to relay data back. But even so, it had new instrumentation, particularly at infrared wavelengths that we didn't have before. So it revealed a lot of new details about Jupiter and how it changes.
When the first image is taken from Galileo of the surface of Europa, first of all, you see the cracks everywhere, but you also see these veins of some material being exposed. Below this crust of ice, which is primarily water, there is a subsurface ocean.
Good afternoon. My name is Dwayne Brown with the Office of Communications, and welcome to NASA headquarters. Today's Science Update will feature new theories concerning Jupiter's icy moon Europa. In fact, what you will hear today opens up compelling possibilities in the search for life elsewhere in the universe.
The Galileo orbiter in the late 1990s detected the magnetic signature of an ocean underneath the ice crust, a liquid water ocean. It did this using a technique that is somewhat similar to the way that metal detectors work, for example, at a beach. Looks for things that are electrically conductive, and a liquid water ocean with salt in it is quite electrically conductive compared to ice.
So Jupiter is 5 times farther from the sun than Earth is, and so we are just so surprised that we were able to, that far out from our host star, find a world like Europa that's able to maintain a subsurface ocean. That's not something that we expected to see. We're able to again maintain that ocean because of Jupiter's gravitational tug on Europa and that tidal heating, but this is something that's really special. It's really special to find liquid water on a moon that is so far away from the parent star in the system.
I think Europa is one of the most interesting places in the solar system because it probably has more liquid water than all of Earth's oceans combined. And when we think about the possibility of habitability beyond Earth, the possibility of life elsewhere in the solar system, we want to follow the water. So Europa is a super exciting place to me, and I think to many other people.
Jupiter is a big planet, so it has a strong gravitational field. So it easily holds in check all of the moons that surround it. And frankly, I lose track of how many moons there are because new ones are discovered all the time. Maybe it's 60, 70, 80, 90. I don't even know anymore because there's so many of them. But the major moons, the large ones like Io, Ganymede, Callisto, Europa, those moons are big. They're worlds in their own right. And because they're large, they interact with one another. And they get into what we call resonances. And that means sort of like for 2 times around this moon, the other one does 3 times around, and then they line up. And every time they line up, there's extra gravitational pull on them because of the moons and because of Jupiter's strong gravitational pull. And that tidal pumping that happens from these resonances, we know warms up the interior. You have what should be ice ball moons actually turning into melted rock moons or liquid ocean moons.
We are now less than a minute away from the end of the mission.
So once the mission was nearly done, once the spacecraft was nearly out of maneuvering fuel, just to be safe and prevent it from crashing into Europa and potentially contaminating that ocean with spores, the spacecraft was redirected into Jupiter, where it burned up into its component atoms.
They're counting down here the space flight operations. A final moment. Great mission, Galileo is gone.
We sacrificed Galileo to save Europa.
Atlantis, Houston, you are...
Most interesting to understand how Jupiter changes over time has been the incredible more than 30 years record from the Hubble Space Telescope.
Houston, Atlantis. Hubble has arrived on board Atlantis with the arm.
Atlantis, Houston, we copy. Nice job, Megan. Nice job on the Proxops flying as well. It's great to be back with the telescope.
Hubble isn't just a satellite. It's about humanity's quest for knowledge. I want to wish Hubble its own set of adventures, and with the new instruments we've installed, that it may unlock further mysteries of the universe.
We have been studying Jupiter regularly for decades now with the same telescope, slightly different instrumentation, but generally the same. And that has allowed us to learn things like that great red spot has actually been steadily shrinking over time. We could see that in the Hubble images over the decades that we observed it. And so the need to continue observing with ever more powerful tools until we get a new mission there, that has only intensified over the years.
And we have engine start and liftoff. Decollage, liftoff from a tropical rainforest to the edge of time itself. James Webb begins a voyage back to the birth of the universe.
Well, I'm thrilled to see that it finally worked, because when we started off, we got a lot of people laughing at us that was impossibly difficult, and now it's done.
And we have a fully deployed JWST observatory.
Well, my dream when I wrote a proposal to NASA to use what was then called the Next Generation Space Telescope to study the solar system, my dream was that it would be a broad program and that we would be able to use this telescope to do many different things. That was a dream. What's so exciting now is this dream is reality. We do now have all these observations from the near-Earth asteroids all the way to the edge of our solar system. And they're all fantastic. They just surpassed my expectations of what they would be. So it's a really exciting time to be a planetary scientist using JWST. We have sent a lot of spacecraft to Jupiter. We orbited Jupiter with Galileo for many years. We currently have an orbiter there called the Juno spacecraft. So you might wonder, like, what could we ever learn with the telescope that we haven't seen when we're right there? The answer is, with a new facility like Webb, you actually can sense different altitudes in the atmosphere than you can with the cameras on the spacecraft that were there in the past and are currently there right now. And by looking at the different altitudes, you can pull out new features.
When we think about the ring planet in our solar system, we immediately think about Saturn. But who else you think has rings? And this is Jupiter, that we tend to never see those rings. So with James Webb, what we did, we actually exposed the planet an incredible contrast to actually map their tennis rings around it. And you can see here this beautiful image of Jupiter, which is fascinating, but you can also see this tenuous ring forming around Jupiter. This is like a small debris of the moons that actually form this debris and makes a little ring. And you can only achieve that with James Webb because it has this dramatic contrast Being an infrared telescope, you can map certain colors which are more difficult, and being a big telescope with that spatial resolution, you can actually achieve that in beautiful contrast for the rings.
When I am anticipating what we're going to see, I have some ideas in my head. You know, I know we're going to see some images, I know we're going to see some spectra, but the real excitement is we don't know exactly what we're going to see because the sensitivity is so much better with James Webb Space Telescope, and the spectrum